Hi everyone, welcome back to the channel. Today we're delving into the fascinating world of Bitcoin with a spotlight on one of its core principles: don't trust, verify. In just a moment, I'll share what inspired me to create this video. But first, let me give you a glimpse of what's ahead. I'm excited to introduce to you this Python script, which I've developed to empower you to effectively independently verify your on-chain Bitcoin balance. How does it work? By deriving addresses from a native SegWit extended public key and fetching UTXOs. Now, I realize that's quite a mouthful of filled sort of technical jargon, but don't worry, we'll break this down into simpler concepts, and hopefully I can clarify all of these sort of technical words for you. We'll also dive into analyzing your UTXOs. So think of them, well, the name means unspent transaction outputs. So we'll talk about those in great detail. And what the script does is it analyzes your UTXOs associated with your addresses and make recommendations on consolidating them based on a bunch of parameters, which again I'll explain later. But parameters like the dust threshold and your average transaction value, things like that. Again, we'll dive into the nitty-gritty of that. And this obviously means that you'll learn to optimize your Bitcoin transactions and manage your wallet a lot more efficiently than you would otherwise. Of course, a lot of these things that I'm going to talk about today, a lot of the modern wallets already take a lot of steps in trying to optimize your UTXOs behind the scenes transparently, so you don't have to worry too much about it. But if you are, for instance, a business that receives payments in Bitcoin, especially businesses that receive a lot of small payments in Bitcoin, then you will probably have these issues that you need to be on top of. Otherwise, your Bitcoin transactions will be gradually more and more expensive over time. So you do really need to proactively manage your your UTXOs that your wallet is creating. Or if you have multiple wallets, then you have to effectively do this for every single wallet you have. But before we get into all of that, let me start by sharing why I felt compelled to do this video. So, the idea behind this video came about when I started basically writing about this in a post on that I shared on X, which you can see here on the slide, and there is a link there. I'll also have any links that I share in this video, they're all going to be in the video description, so do check those. In particular, I recommend that you read this particular post that I wrote on X, which I think complements this video really, really well. The post basically talks about, in some detail about what caught my attention one day when I was using ThorSwap. Again, if you don't know ThorSwap, it's really a tool that you should explore. If you love decentralization, if you want to avoid using centralized exchanges to make swaps, etc., like any other DEXs, ThorSwap is one of the few that allows you to swap in and out of Bitcoin whenever you want in a completely permissionless way, and that's quite a massive advantage. Of course, we always want to keep our Bitcoin and we don't want to swap out of it, but if you need to pay some expense on your real life that you need to unfortunately swap a little bit of Bitcoin to get some fiat trash to pay for stuff, then you can use services like ThorSwap. So I noticed that there was a discrepancy between what my Ledger wallet was showing as my Bitcoin balance and what I knew to be accurate from Ledger Live. So this was obviously enough to spark my curiosity and, push me to dive deeper into how Bitcoin addresses, UTXOs, privacy, and even wallet mechanics really work. I ended up writing a thread about the entire experiencing, which is basically the one that you see here on the screen. And in this thread, I talk about like Bitcoin addresses, UTXOs, I talk about privacy, I talk about wallet coin selection, which is a feature that I'll talk about in the end of this video. The role of change addresses, this is another thing that you'll become aware of as I explain, as I go through the video, and ultimately how Bitcoin transactions sort of function under the hood. So this problem that started with ThorSwap kind of showing me a different balance than the one that I was expecting, sent me down this rabbit hole of trying to understand how Bitcoin actually works behind the scenes, or more specifically, how Bitcoin wallets work and the different types of addresses, the UTXOs, which is one of the things that a lot of people are not aware of, but this is how Bitcoin actually works behind the scenes. And this experience really changed how I look at Bitcoin, and it's essentially what led me to create this video. It led me to create that post on X first, and then actually as a result of this deep rabbit hole, I ended up writing not only this post, but I also wrote another post actually yesterday about the programmability of Bitcoin and Bitcoin script and the cool things and use cases that Bitcoin can actually serve. And I didn't realize that Bitcoin could be this flexible. So I'll talk about this in this video as well a little bit, just a few seconds, just to briefly touch on those. I'll point you again to that link on my post on X that goes into some of this, but I was like super excited when I learned about all of this. And yeah, so obviously the Python script that I'm going to show you now obviously can verify, you can use this script to very independently verify your Bitcoin balance, as I said, but also to manage your UTXOs. So you don't really have to trust what your wallet tells you. Yeah, so let's just dive in and go through the details. Right, so the first purpose, as I was saying, of the script is to derive wallet addresses from the native SegWit extended public address key. So you will get this key, in my post on X I talked about this, but you will get this key from your wallet. So you will have to, like each wallet will have different menus that you can explore, but you will eventually, or you can Google it, but essentially you can find this extended public key from your wallet. A word of caution, and I mentioned this on the X post. You should, even though it's a public key, you should really not share it with anyone if you can avoid it. The reason being, so that the extended public key doesn't give anyone access to your funds, to your Bitcoin in this case. So if the key was leaked or stolen, it's fine in the sense that they cannot take your funds. What is not fine is that it's a huge loss of privacy. Why? Because that key can generate, as you will see in the script, that key can generate all of your wallet addresses. So they will know your current balance, but they will also know your future balance and all your future addresses. So yeah, it's a piece of information that I think you should really you should almost keep almost as private as your private keys, of course, that give access to your Bitcoin. The script also obviously retrieves, so for each address that it derives from your public master key kind of thing, It also retrieves the unspent transaction outputs, your UTXOs for each of those addresses. It calculates the total on-chain Bitcoin balance associated with your public key. So this was the original, like my reason for writing the script was, let me just, write a piece of code that can effectively give me assurance and confirmation of my Bitcoin balance, even without trusting my Ledger Live app. I can just do it independently myself. So that's one, and it's again because of the Thor swap situation, the discrepancy that I was showing. But then I enhanced that script afterwards. After I wrote that X post, I actually, like a few days ago, I enhanced that script to actually then manage the, like, provide recommendations. Now that I had access to the UTXOs, I could easily just do a few checks on each of the UTXOs to tell me whether I should optimize or manage them. I always had heard people talk about these things before, but I didn't really understand what they were. And now I do, because obviously I had to develop this code to actually look into the nitty gritty of behind, like Bitcoin addresses and UTXOs and what they are. So let's go further down. Yes, key features. The script obviously only focuses on the SegWit addresses, so the more modern types of addresses on Bitcoin. It doesn't focus on legacy addresses, but it's not a problem, because if you want, or if there is sufficient demand, I can actually update the script to actually work with legacy addresses as well. But for the time being, it only works with SegWit addresses. And it incorporates best practices for UTXO management, or at least I'm not claiming I'm an expert in UTXO management. These are the things that I found online by Googling it and searching, that are things that people normally use, like these types of values and things. But feel free to disagree with me, and if you find better numbers or better rules, or rules of thumb or best practices to manage your UTXOs, please, by all means, leave a comment down below on the video description or on the comment section. And when I say avoid reliance on third-party wallet tools, I was primarily just talking about, like, verifying my balance without relying on the wallet. But the wallets are still obviously very useful, especially if you use a wallet with a coin selection feature or a UTXO selection feature, which again, I'll touch on this at the end of the presentation. Right, so understanding dust thresholds. So the dust threshold varies depending on the transaction type due to differences in transaction sizes and fees. Because the script focuses primarily, or only on native SegWit addresses, we use the lower dust threshold of 1,000 satoshis, and being aware of these thresholds helps in maintaining a healthy UTXO set for your wallet. As you can see, for legacy transactions, the UTXOs, sort of the threshold is higher, between 5,000 and 10,000 satoshis. That's what I kind of found after doing a little bit of research. But so the script, I configured it basically for 1,000, which is the lowest level. Yeah, so let's continue. What you see here is an example of the output of the script. So as you can see, when I run the script, in this case, I run it by doing this, Python BTC balance, blah, blah, blah. That's the name of the Python script. And then it prints out all of this. As you can see, it prints all the derived addresses from the public key. The public key, I configured the script so that it reads the public key from a file. So if you were to run this script yourselves, you would have to obviously configure the key in that file before running the script. But yes, it takes the extended public key from that configuration file, and then it basically uses the key to derive all of these addresses. So it you will see later in the code, but it looks at two distinct sort of sequence of addresses to actually capture all of your addresses where you have Bitcoin or you have UTXOs. But effectively, you see, all of these derived addresses with the UTXOs underneath for each of the addresses. So each address will have one or more UTXOs. And then it prints your total Bitcoin balance, as you can see here. And finally, it asks you for your average transaction values. I entered 0.1 in this example. And as you can see, it says, you have 6 UTXOs that have been identified. You don't have any UTXOs below 1,000 Satoshis, which is good. So you don't have any dust or UTXOs that are in danger of becoming completely unretrievable or you cannot spend that Bitcoin because it's just like the fees to spend it would be higher than the value of the Bitcoin of those Satoshis in there. And then the UTXOs below your average transaction value, it says that it identified 2, and then it sums them up to tell you how much Bitcoin that is. Again, all of these values are fake. I just made this up so that you can see exactly the type of output that the script produces. And as you can see here, it produces a recommendation as well saying, it's advisable in this case because it found that there are a couple of UTXOs that are below your average transaction value. It basically is telling you that you should, do something about optimizing that situation. Right, so now talking about the script itself. So now we're going into the deep details of the script. So it starts by importing a few libraries. The key important one is this BIP_utils library, which is crucial for deriving the addresses using the BIP 84 for native SegWit addresses. So BIP, I believe it stands for Bitcoin Improvement Proposal. And then we also use requests for HTTP requests to query external APIs, and we use JSON and sys as well, which are basically standard libraries for handling JSON data and system functions like exiting the script when I want to exit. So things like that. The second part of this slide is talking about the key parameters that you can configure on the script. It talks about the dust threshold. So in this case, it's set to 1,000 Satoshis. And the estimated fee rate, which I've set in this script to 5 Satoshis per V byte. We'll talk about V bytes in a second and what that means, but essentially this is a way. So what the script does is it calculates based on the number of UTXOs that you need to optimize. It tries to calculate what the most minimalistic transaction size would be, and then multiplies that transaction size by the fee rate, which is the number of Satoshis that it's going to cost you. So the cost of a transaction in Bitcoin, a lot of it is influenced obviously by the transaction size, like how large is that transaction. And there is a certain rate that you can expect to pay for that particular size. I set it to 5, but it can be a lot less. I checked like just a few minutes before I started this video, it was even below 1, but it can be a lot higher than 5. The other day was like 3, so it varies, every day is different. So you should, like, if you're gonna run this script to check your personal wallet, like your wallet situation, you should always go to the mempool.space is an example of a good site that you can just go there to check like the real-time rates, and then you just take those numbers, put it in the script, and run the script with the actual Satoshi number of satoshis per byte. One thing to know, I'll probably say this a few times during the video, but you need to pick low traffic times of the day to actually do this, because you want to optimize so that the transactions cost you are there as cheap as possible. And one of the things, just before I go to the next slide, one of the things also that I also talked about this on my X post. That's why I keep saying it's a good complement to the video. You should read that post. And if you like it, please like it as well and follow me on X, because I do post quite a bit sometimes there, talking about some of the findings that I don't have a video for everything I find, so sometimes stuff just ends up on X, but this one was special, so I had to make a video about this. But in that X post, I think I also talk about the fact that one of the best practices should be that you should, when and this is very, very true for people that do DCA, let's say a part of their salary into Bitcoin every month. You should not transfer small amounts from the centralized exchanges if that's where you buy your Bitcoin. You should not transfer those small amounts like constantly every time you DCA. Perhaps, of course, there is risk associated with this decision, but perhaps you should let the amount in the centralized exchange grow to a certain level, a certain number of Bitcoin, and then when it gets to a high level enough, and this changes, of course, for everyone. Everyone will have a different number in mind. Just choose a number that you feel comfortable with. Let's say for example, I use, let's say, 0.1. So what I could do is have a rule that says every time my balance in the centralized exchange gets to 0.1 Bitcoin, I want to take it to my hardware wallet, to cold storage. So in doing that, what I ensure is that I never end up with UTXOs that are like too small, close to being considered dust. So I want to end up with a lot of UTXOs that are chunky enough, like have a good significant number of Bitcoin, so that my transaction fees are going to be a lot lower. Especially, for instance, if my transaction transfer, like when I spend my Bitcoin, if I spend it in such a way that is like maybe less than 0.1 a time, then that's even better, because we know that the transaction size overall is going to be small, because most of my UTXOs, which are chunks, effectively UTXOs are chunks of Bitcoin. So every time you receive Bitcoin from like a centralized exchange or from a friend that sends you Bitcoin, I wish I had some friends like that, but it's like Max Kaiser that gives away Bitcoin. He doesn't do it anymore, but he used to do it. I think there are lots of stories about that. People that he gave Bitcoin and lost it, or don't know what they did with it. Anyway, the point is, when you receive Bitcoin, there is a new UTXO that is created, which effectively is associated with a new address, because most of the wallets, standard best practice to protect your privacy again, is that they create new addresses every time you need to send Bitcoin to your wallet. So that's why you always see different addresses every time you send Bitcoin to the wallet. And that means if you have a new address, you have a new UTXO. Now, you could end up having multiple UTXOs associated with the same address, of course. If you reuse the same address multiple times, you will end up with multiple UTXOs, but by default, your wallet typically creates a new address. Anyway, I think that's it. I don't need to talk about this much further. Let's continue. Script functions. So fetching UTXO. So this is the Python function that fetches the UTXOs. And it's nothing special about this. It uses the Blockstream API to retrieve all the UTXOs. It handles the HTTP responses, returning the UTXO data back in JSON format. If successful, of course. If not, it prints an error message. Very, very simple, nothing special about this. Blockstream is like a block explorer. You could, so this is the thing. So I didn't want to make this script too complex, but I was like thinking if I had downloaded like the Bitcoin client node sort of, which would force me to download all the history, probably I would require like hundreds of gigabytes in my hard drive to do it. But I could perhaps not use this. I could just use the the direct Bitcoin RPC sort of way of getting this information, but I didn't want to make, I didn't have the time or the space or the energy to do it. I will very likely do this at some point in the near future, but for now I just wanted to get like the script ready very quickly, so I did this. I think it's a reputable, block explorer kind of website, so should be fine. But if not, this can be changed to use an alternative. Estimating transactions virtual size. Right, so this is this slide we'll spend quite a bit of time on here, so let's go through this. So in this, so as you can see, the amount of time we're going to spend on this slide is not directly proportional to the size of the function. The function is actually quite simple. It's just this. It receives an input count and an output count. We'll talk about that in a minute. And then it basically says, okay, an input size is 68, output size 51, overhead 10, and then it basically has a formula that returns a size based on those two variables. So, of course, this estimation is crucial for calculating the transaction fees. And transactions in Bitcoin have input UTXOs and output UTXOs, as I was talking about earlier. The more inputs and outputs, the larger the transaction, and of course, the costlier it will be. So let's talk about bytes and V bytes and like what's the difference between the two. So bytes and V bytes are referring to two different metrics: the size in bytes or the virtual size, as in V bytes. So the size in bytes of a transaction refers to the raw byte length of the transaction serialized format. So it is used to measure the sort of data footprint of transactions when relayed to the network or stored on disk. So this is like the actual, if you serialize a transaction and save it in your hard drive, it will have a certain number of bytes size, and that's what everyone understands normally as a byte, as size in bytes, like a file. And then you have your V size, which refers to a transaction weighted size under the SegWit rules. It is used to compare how much block weight needs to be allocated to confirm a transaction. I pulled this straight from the internet. There is lots of definitions on it. I'm not going to spend time now going through the formulas and the different ways that this is used. But if you want to search it online, a quick search on Google for V size, Bitcoin, SegWit. If you search for that, you'll find like lots of detailed information about this. But I just wanted to briefly mention, because obviously there is V size and virtual size and the actual size in bytes, and you probably wanted to know exactly why V byte. Everyone knows what a byte is, but no one knows what a V byte is. So yeah, there you go. Just know that they're different, slightly different. So, but essentially it's the same as in a V byte is an estimation of a size for a transaction, and therefore that is used to calculate how much ultimately the transaction is going to cost. So as I say here on the slide, there are three elements that are important when trying to calculate the size of a transaction. There is the inputs, the outputs, and the overhead. So let's talk about the inputs first. So as I say here, the inputs are three primarily. So you have the previous output, which I'm saying is 36 bytes, and it's 32 bytes from a transaction ID. So every UTXO came to being as an output of a transaction. So that means that some transaction originated this UTXO, and this transaction ID is appointed to that transaction. The second 4-byte one is identifies the specific output from that transaction, because each transaction can have multiple outputs. So this field indicates which one is being spent, like what's the index of the UTXO of that transaction that is being spent. As you can imagine, this allows for great transparency and auditability. You can trace everything back to the inception block that had the original first transactions in Bitcoin. It's quite amazing, this what this allows you to do. This I talked about this on my X post, that there is the UTXO model and the account model, which is basically what other blockchains use, like Ethereum and Solana. They use these account models, which are not based on UTXOs. I personally think UTXOs are more, it's easy to understand, conceptualizing in your head why they would be better in terms of transaction, in terms of auditability. Let's put it like that. Sorry, I was just switching off something here that was probably creating a lot of noise in the video. Anyway, let's talk about the sequence here. So sequence is 4 bytes, and this is basically a mechanism that is used for time-locked transactions. So if you want to delay spending the input, you could use this. It's generally set to a default value if block time is not being used, and this is a mechanism that I didn't realize at first, of course, until I started looking into this in more detail. I didn't realize that Bitcoin has this level of flexibility, but the idea behind this is that there are lots of use cases in the real world where you don't want to spend straight away, and again, in one of the posts that I wrote on X, I do talk about this in terms of the use cases. Things like dispute resolution, savings or trust funds, escrow services, multi-sig wallets, you name it. Like, there are a number of situations where you don't want a transaction to be finalized right there and then. You want to have certain other conditions to be true before the transaction is effectively executed by the miners and added to a certain block. So that is the idea that Bitcoin can have this level of programmability is quite profound, because most people think of Bitcoin as like a network that obviously doesn't have smart contracts in the true sense of the word, but it does have Bitcoin script that you can embed in the Bitcoin transactions to achieve a certain level of configuration and condition setting that allows the funds to be unlocked when certain conditions are met. And this is quite powerful. This allows Bitcoin to be very, very, out of the box useful for a lot of these real world sort of use cases that, I just mentioned. So yeah, so this is really super interesting, and I highly recommend that you do a little bit of research if that's like if those use cases are something that you might want to use in your business. Who knows? The third and final point for the input UTXO size estimation is the witness state. So the witness state is 107 bytes, but it is going to be discounted approximately to 26.75 virtual bytes or V bytes. So SegWit, basically SegWit addresses introduced sort of the witness field where the signature and the public key for the input are stored. So, and yeah, and basically this 107 sort of byte data includes the signature, which is roughly between 71 and 73 bytes, depends on the signature format, and the public key, which is like about like, I think 32, 33 bytes, something like that. So this is the final element of the UTXO input, basically meaning that that's how much it, like 68 is basically what it comes roughly what that size of that UTXO would be. Then you have the output. So the output is smaller in size, and the output has primarily basically two fields, as I say there. So there is the value. So this field represents obviously the number of Satoshis being sent to the recipient. It's an 8-byte integer encoding that value. And then you have the really important one, which is the script length and script pub key, which is about 23 bytes. So when you use this output UTXO as an input for a new transaction, the script pub key from this UTXO remains unchanged. So what I mean by this is you can encode Bitcoin script instructions in this field, and what that does is once that is there, it's immutable. You cannot change it. It's not like in a say a smart contract platform like Solana, for example, or Ethereum, where you can upgrade the script or the program, let's say. Here, it's embedded in the transaction, very, very different from the other smart contract platforms, and it's immutable, which is great in a way. So, and it had to be like that, of course, because if you think about like the real use cases that I was talking about earlier, say that I'm buying real estate and I am putting a collateral up for the purchase of the house, but there are a certain number of conditions that need to be met in order for the funds to be unlocked and transferred over to the destination account. You want the conditions, once they're set by me, for example, or by another intermediary, that those conditions are not mutable. Like it's your safe, like it's the sort of, say, let's put it this way, it's the contract that both parties agree to, and those conditions should be immutable. So this is the reason why it's really important that that element of the UTXO is like, it's locked. You cannot change it. So what that means is that to complete like the transaction, you need to satisfy these conditions. And yeah, and that's all I have to say about that. And finally, you have the overhead. So again, this is the least important element. I'd say it's, I found that it's like about 10 V bytes. You have version fields in there because transactions have version numbers and different transactions have different rules associated, I believe. You have marker and flag, which are needed if you're using SegWit, and you have lock time. So this is like a transaction level metadata field that can be used to specify when a transaction becomes valid, either at a specific block height or a certain time in the future. If this is not being used, I believe it's set to 0. But again, it's interesting because what you see here is that you can have, for example, conditions set at the transaction level, let's say with this lock time. So the transaction can only be sort of processed at a certain point, maybe in the future. But you can also set this at the UTXO level. So there is a lot of granularity of configuration that you can set up in a Bitcoin transaction, which is quite, like, I believe not many people know this. So this, as I said before, gives Bitcoin a lot of flexibility that I had no idea Bitcoin had this level of flexibility. I mean, I'm very glad that I started kind of digging deeper and deeper into it. As people, there is that meme that there is like this iceberg, and what people know about Bitcoin is like just the very tippy top of the iceberg, but they don't know the whole monster body of knowledge that is under the water. And you know, it's quite a nice meme because it kind of represents what most people know about Bitcoin. It's quite kind of close to nothing. And I've been a fan of Bitcoin for a few years now, um, and I thought I knew, you know, a significant portion of significant sort of portion of knowledge about Bitcoin, but I honestly I had no idea that there was so much. So yeah, it proves that you're always learning, and there is always more to know. And I'm pretty sure that even though I now know all of this, I only scratched the surface. There is a lot more. So as a software engineer, for me, this is like something that I really want to continue doing, is exploring this more and more and more and developing in Bitcoin. As I said before, even though I've been working, some of my other videos that you have here on the channel, some of them talk about smart contracts in other platforms like Solana. And that's just because I've not, you know, the type of stuff that I'm trying to build probably really only works on Solana. But I am desperate to find like the next Bitcoin layer 2 where I can actually do the, you know, develop the equivalent smart contract on layer 2 on Bitcoin. And I'm very keen to do that in the future. And as soon as I have like a feasible one that I can use, I'll start sharing my experience of developing on that Bitcoin layer 2. Anyway, sorry, I went off on a tangent. Let's go to the next slide. So in this slide, just a little bit about Bitcoin addresses, external versus internal change addresses. So this is actually quite important to talk about because the script, as you will see in the next slide, will show this chain underscore ext and chain underscore eint. So this is external and internal. So chain external, chain internal. So let's talk a little bit about this. So what this slide basically is trying to convey is that there are two main types of addresses used in Bitcoin hardware wallets. There are the external addresses and the internal addresses, also known as, so the internal addresses are change addresses. So the term, let's clarify the terminology here. So the term chain here refers to the fact that the wallet is generating sequences of addresses, allowing different branches or chains of the derivation tree. Both external and internal chains use the same extended public key, but allow different derivation paths to ensure privacy and efficient wallet management. So if you imagine this is basically just a sequence of addresses that you get, like the root is your extended public key, but they have slightly different functions that generate these two different sequences, one for external addresses that you will use when you want to receive Bitcoin, and one for change. We'll talk about that in a minute. So when you receive Bitcoin, the wallet automatically generates this external address from the external chain. These addresses are obviously publicly shared to receive payments and to protect your privacy. The wallet typically generates a new address each time you want to receive funds. We talked about this before. On the other hand, when you send Bitcoin and have leftover change from the transaction, the wallet generates an internal address from the internal chain, the chain underscore int. These change addresses are not shared publicly and are used to receive the leftover funds from a transaction. A new change address is generated each time to enhance privacy. All of this happens automatically in wallets, as I mentioned before, that follow the standards like BIP44 and BIP84. The wallet manages both internal and external addresses and tracks your balances accurately across both chains, so you don't need to worry about doing any of this manually. Of course, all of this is happening behind the scenes, but as you can see, it's quite interesting. And one of the things that you need to remember is that when a transaction is processed, all the inputs are consumed. So your UTXO, the reason why there is always going to be, well, one of the reasons, there's more than one, but one of the reasons there's always going to be change, unless the Bitcoin that you're sending actually consumes perfectly all the UTXOs, which is probably rare. Most of the time there is always some change left. So when this happens, it's not like the UTXO is updated to reduce the balance of Bitcoin in that UTXO. What does happen is the UTXO is marked as spent, and if there is leftover, the wallet creates a new address in this chain int, which basically it's a new address that will get the leftover Bitcoin, and the wallet puts it there. All of this obviously is done behind the scenes. It's transparent for the user, but this is how it works. So now, if I show you this code, now it will, with that explanation, hopefully this will make a lot of sense. So let's go through it together, because this is the core of the script. Like everything else is maybe not as important, but this one and the next one actually are the two important elements of the code. So as you can see here, we use the BIP84 standard for deriving the native SegWit address for the extended public key. The gap limit defines how many addresses we scan in each chain, external and change, or external and internal. And we collect all the UTXOs for these addresses for analysis. Now, one thing that I need to mention, this gap limit is it's a little bit confusing to understand, but effectively what it is when you're deriving addresses, not all addresses, this is, you can derive addresses infinitely, right? So there's tons and tons of addresses that you can generate, but not all addresses will have UTXOs, your Bitcoin. So what that means is, what the script is doing is saying, okay, when I hit an address that doesn't have a UTXO, should I give up finding new addresses at that point in time as soon as I find one that doesn't have UTXOs? And for safety reasons, I think there is like an accepted best practice that says you should only stop about like after 20 addresses that you generated that do not have UTXOs. You probably are safe to stop at that point, because this is a deterministic sort of derivation sequence. So if you've got, like, you probably could have even stopped even earlier, but just for the sake of being safe and not missing Bitcoin that the customer actually, or that the user actually has, it's better to basically just carry on checking, and at the point that you find 20 consecutive addresses that have 0 UTXOs, that's probably safe to stop generating new addresses. So that's what that gap limit is. And yeah, so this code, as you can see here, it's basically doing it for the chain external and chain internal. That's why we spent, there's a reason to the madness that we spent talking about like this chain external, chain internal. So it's doing this for both. Um, and yeah, we look through the indices up to the gap limit. We derive the external receiving addresses and we derive the change addresses. That's it really. As we go through it, we collect the UTXOs for each of the addresses. So we fetch the UTXOs for each derived address. We accumulate the total balance because as you can see here, we are doing total Satoshis plus equal UTXO value. So we are summing all of them up. And we store the UTXOs data for analysis later, as you will be able to see that in a minute. But we have an array and we keep adding, like as we find the UTXOs, we keep adding those UTXOs to the array, regardless of whether they are internal or external. We keep them all in the same array, so all UTXOs is this array there. Right, so what else do I want to say? So yeah, so this is basically the total Bitcoin calculation. So at the end of these two loops for external and internal, we get to the point where we can actually um, calculate the number of actual Bitcoin. So we change from Satoshis to Bitcoin. Obviously, every Bitcoin has 100 million Satoshis. So we divide that by 100 million to get like the actual Bitcoin number. And that's what it does here. It prints the total Bitcoin and then it asks the user, what's your average transaction value in Bitcoin? And this is important because it's one of the ways to optimize your UTXO. So say that you're a user that on average when you send Bitcoin to someone, or to one of your other wallets, you typically send in chunks of 0.1 or 0.5 or 2 or 3, depends on how rich you are in Bitcoin terms. But it tries to see, and this is obviously important. Why? Because if most of your UTXOs are under this threshold of your average transaction value, that means that you probably should consolidate. And that's what this is trying to do. It's asking you, what's your average transaction value? Yes, that's it. And then it calls this function, analyze UTXOs. So that's what we're going to see next. So here we are. So this function is actually quite simple, and it focuses on these two categories of optimization. So first, dust UTXOs are uneconomical to spend, and individually they can clutter your wallet. And small UTXOs may require like small as in they're not dust, but they are below your average transaction value. So these small UTXOs may require multiple inputs in future transactions, increasing obviously the fees. By analyzing these two categories, we provide targeted recommendations for consolidation, as we keep talking about. So we obviously use that estimate transaction function that we talked about in previous slides. It calculates the size, and then it uses the estimated fee rate, the 5 that we talked about in the very beginning of this presentation, to then estimate the cost of the transaction as a whole. So for dust UTXOs, if the total value of the UTXOs is greater than the estimated fee to consume them, then we basically tell you that you should do something about it. Same applies for small UTXOs. In this case, I actually said if you have more than one. So if you have one, we say fine, whatever. But if you have more than one that are under your transaction value, we recommend that you should optimize those as well. So Yeah, so and the recommendations will look something like the output of the slide, the output slide that I've shown in the very beginning of this presentation. Yeah, that's it. I mean, this code is very, very simple. There's really nothing too spectacular about it. And yeah, let's go to the next slide. So transaction fee rate consideration. So fees are calculated per virtual byte. Network congestion affects obviously fee rates. The more congested the network is, the more expensive these fee rates will be. There is a really, really good site like mempool.space that you should really check it out. It has the real-time fees, and this is where you should go there first, get the number from there, and update it on the script before you run the script. Yeah, that's it. Next. And we are almost at the end. So, what are the instructions for consolidating your UTXOs then? So, you should use wallets that have coin control. So there are some wallets out there that you can search on Google, and you can say, Bitcoin wallet, coin control, UTXO, something like that, and you will find a few, as I did find, that allow you to basically connect your ledger or Trezor or any other sort of hardware, popular hardware wallets to safely select your UTXOs for spending them, and then obviously send it to one of your addresses. So effectively, the way to consolidate UTXOs is it's a transaction where you send from one of your addresses to another address, and but the important thing here is that you're allowed, the wallet that you're using allows you to pick the UTXOs that you want to spend. So you should choose the dust and small UTXOs identified by the script. So you run this script before doing this, of course, and you send the combined amount to a new address that you control. And you should obviously set the fee rate adjusted to the network conditions, as we talked about earlier, by going to that website, the mempool one, and yeah, and then you confirm and sign the transaction on your hardware wallet, and you should send it. As I said before, consolidate during periods of low network fees. You will see that if for instance, if I look at it in the early morning, my time, so I'm in this sort of the GMT time zone. So when I look at it in my timeline, so in the early morning, it's like really, really cheap. It can be 3, 2, 1, even less than 1. So it's perfect time for consolidating UTXOs. I've never done it because I have not needed to do it yet, but eventually I will have to do it. So when I do it, I will definitely pick a time like that, like really early in the morning, that I know that the network is not very congested, and so it's ideal for cheap transactions. But as I say there in the last sentence, be very mindful of your privacy implications. So the more you do this, the more you leak privacy. Again, in the X post that I had, I do talk about this in more details. So check it out. Yeah. So final conclusion. By using this script, you're basically not only verifying your Bitcoin holdings without relying on third-party tools, but you're also gaining insight about which UTXOs you should actively manage. Effective UTXO management enhances your experience and can save you a lot of money in the future. Yeah, you should continue learning about this and adapting to make the most of your Bitcoin transactions. I certainly did, like going into this deep rabbit hole after I spotted that discrepancy in ThorSwap. It was great because it allowed me to learn a lot about how Bitcoin actually works. Do let me know in the comments below if you have any other best practices when managing your UTXOs, which I should maybe consider implementing in my script, and then I can share you share some feedback about those. And if you liked this video, please consider dropping a like, a subscribe, and activating the notification bell so that you know when I post my next video. Thank you very much for watching. I know this was a long video, but stay empowered and stay decentralized. Thank you very much.